Here's another post hoc test. It's called the Dunnett's test, sometimes pronounced Dunnett's test. What is it? It is a new formula that's going to compare a single group mean from an ANOVA to all the other group means in that same ANOVA. Normally, it is used to compare the control group mean to the experimental group means, and it is going to be a new test statistic, and every time we have a new test statistic, we have a new critical value table that we have to look up from the book. There's the table, Dunnett's critical value table. And again, there's going to be a new formula. So there's the formula. The D stands for difference. Sub Dunnett equals T times the rest of that mess. A good mnemonic trick to remember the Dunnett test is it ends in two T's, and it acts like a t-test by comparing two groups. So we're going to do a quickie example on how to find the correct T sub Dunnett from the table. What we need to figure that out is we need to know how many groups there are. We need to know how many degrees of freedom from the within group from the ANOVA source table, and we need to set our alpha. We know from our rat study that there are 5 different groups, and then let's set the alpha. That's pretty easy. We'll just count alpha as 0.05. And then how many degrees of freedom from the within group, we go back to our super rat ANOVA, and there it was, 20 underneath the degrees of freedom within group. So now we know we have all the information we need to look up the t-test statistic from the Dunnett table. So let's get that first number. There's the data we need. There's the table. Make sure you're on the right page. Our alpha is 0.05, says it up in the upper right-hand corner. And the top row tells us how many groups, so we're in the 5 column here because we got 5 groups. And we go down to the 20th degree of freedom row. Those are the ones on the vertical side. And where they intersect is our new T. So there it is right there. It's 2.65. So let's plug and chug. Found that one. Now let's find this mess over here. So we have to go back to our source table to find our mean squares of the within group, which was 14.38, and then we have to plug and chug the real values in. N is the number of individuals in one group, and we had 5 rats per group. So we do a little bit of math, and now we know that number. We plug it back into the formula, do a little bit more math, so we get a final D sub Dunnett equals to 6.356. What that means again is that if two means are greater than 6.356 apart, that means that you have a significant difference between the means. You got it? Good. So we're going to go ahead and check out our data from the Super Rat study. Let's go back to the means. Here's all the different 5 group means, and remember that the A1 was the control group. So we're going to be comparing A1 to all the rest of them. So let's start with A1 versus A2. We're going to subtract the differences between the means, and we get 23, which of course is greater than 6.356. Therefore, we have a significant difference between those two groups. And we're just going to go ahead and finish all the rest of them. So here's A1 versus A3, A1 versus A4, etc., etc. And we're just taking the absolute value of the difference between the means. And as you can see, the differences are all greater than the Dunnett's difference. Therefore, they're all significant. So in a nutshell, we have just discovered that all treatment group means are significantly different than the control group mean. And that is all. MGZ out.